How's it going, everyone? Welcome. Elder Gonzalez here. And well, today is just a day where we're going to explore about is the chapter 3. To describe now briefly is first, how do we get here? So we can now take a look at this appendix, where it is. Get started here on the appendix A, which is something that we know, values versus reference, uh, so many forms of values, and coercive conditional comparison, as well as the prototypal classes and how this truly things works. But most important is the exercise that I want to do here, right? Which is here as a way to understand, as a way to put a test our understanding in prototypes. Okay, so because on chapter 3, this is when we look at these low level features in JavaScript that affect virtually every line of code that we write, and understand the how JavaScript feels, the feels of JavaScript, and how it is, and how ebbs and flows. It first to on chapter 1 is, hey, let's go to now look at the what is JavaScript. Okay, so we went through what is JavaScript, who makes that, the legal trademark, who now oversees the JavaScript as the technical spec, which is the TC39 group, who makes this group, what they do, what is their goal, which is don't break the web, and on that also that because all of these JavaScript implementators, uh, some of them deal the reality, whereas the TC39 now live on concepts and spec. Uh, because this mismatch happens, sometimes they don't have is the full picture. They commit, and well, things like the smoothgate happens. So it turns out that despite that the TC39 is making its best efforts to provide all of a set of rules, but sometimes they have to go back into the drawing table. And because we can now run this spec in different environments, all right? Well, each one of them has their own particular API that they can go with. You can use it. So the idea is that the only reality that matter across all of these different JavaScript implementation is the web, and how now the console is not a true spec compliant JavaScript environment. It's just it was meant to be is a helper to debug small things, okay, and also in an effort to don't break the web, the TC39 as well as the community has created things like known as Polyfills, which is way to guarantee now new features can be executed by other browsers. So they provide the behaviors if they don't have them. And also, to understand now JavaScript in itself, we look at all of the different approach that we can write, okay? Whether it is the JavaScript, uh, yeah, whether it's whether it's object programming, functional programming, and so on and so forth, functional, object programming, and procedural, and in the context of JavaScript, how important it is to understand that JavaScript is not an interpreted language; it's a compiled language, because in essence, if not in practice, the way how now JavaScript is treating errors is similarly of how now compile language treat them. All right. So because of that, uh, the language in itself now that have this parse and execution phase, uh, the community back in 2013 11, they now wants to put that on test. So a bunch of Mozilla engineers, they pour the Unreal game into the web to show that the language in itself can now actually run these games or heavy lifting applications, right? That are written in another language. So by passing now a certain hints to the JavaScript engines to run some optimizations, they now create this subset of JavaScript, now the ASM. So years by, and we have now these things called WASP. So WASP is this spiritual successors that say, hey, let's go to take a step further, and now let's get rid of the parse phase by creating an intermediary language that resembles like an assembly or that look like an assembly, where we skip that parsing phase and we only focuses on the execution. So this language now will become is this universal compiler, because we can take any particular JavaScript language out there and then compile that into the WASP code that can be executed in this WASP environment. So now WASP has become this universal compiler target uh, that can be run inside of this WASP runtime. Again, this is not an intent to replace JavaScript. Is in fact is an attempt to see that you can have now a language or in an effort to take a language, all right, and whatever language that you wrote your applications, so you're gonna pour that to be run in this execution environment or in this environment here. And because now in JavaScript we also have this particular guidelines known as the strict mode that tells developer the right things to do so that the compiler has has a good chance of optimizing and executing your code. This particular guidelines that doesn't behave the same in the console log as an application written in JavaScript, right? So because on this chapter 1 we went through all of this, and in chapter 2 we describe is the serving JavaScript, okay? Serving your knowledge in JavaScript by first looking at how JavaScript see programs, that each program is a mini files, and how these programs, which is a standalone, the only way that they can cooperate or act as a single one, quote quote, is by sharing their state, whether it's sharing their internal state or a global state, or in the case of the ES6 model, is by now linking all of these different files via the import. So no matter how co-organizations or linking mechanism that you're using, uh, each file, it is safe for us to think that each file is a mini program that can cooperate with any other programs or mini programs at runtime. So because this program is this set of instructions and set of instructions that need to describe values to represent something. So values are the way of how we can manage the state of our application, of our programs. So we have different way of how we can represent those values, whether it's a string or a number, and how now they have a specific spec to describe how they're gonna look like. So for example, in the case of a string, back in the old days we use now Unicode. We use is the Interesting. ASCII characters that represent is a small set of characters. It's a map of uh, Latin characters, specifically English characters. But because that fell short as the years go by, well, now the is made of a commit that decide to say, hey, because this is a challenge that we're gonna face, so this will be now the new mapping here, or the new encoding. In other words, the new character set that computer must use in order to represent all of these possible symbols, whether it's Latin symbols or Western English, French, Brazilian, or Spanish, as well as Middle East, Arabic like, right? And also the hand-based characters, the Chinese, Japanese, South Korea, and so on, and among others. Not only that, so this Unicode, which is used by Stream to represent all of these symbols as a sequence of characters, and also is a number, which is a way of how you can represent now finite numbers, and how we have, for example, accuracy problems because you want to represent is a fixed length of numbers because you don't have infinite memory, right? Uh, so this is pretty basically these two values. So we also have now booleans, symbols, big in kind of emptiness like null and undefined, as well as the objects. And how now in objects, JavaScript or the spec look at this and say, hey, this is now ordinary objects, and then I also have something called exotic object, which is a fancy way to say it's like a subcategory of objects. So you in this now enter things like array like, all right, which is a numerically indexed collection, and also the functions. So functions also are values, and this is something important because it's going to unlock now a different uh, world when it comes to compute or describe its computations or calculations here, right? So it unlocks now a new set of patterns that we can use to do that from the functional programming. So I also look at, well, now how this value can be described or how it can be used inside of our variables. So you have now literals, uh, or you can hold those values inside of a variables and using a syntax specific form that has inherited behaviors, and where we can define and use those variables, right? So for example, var, let, and const, and also is the uh, functions declaration, which is another way how we can define variables in the environment, and inside of the function body, it is another place where we can actually access to a variable in the try catch, especially the catch error. And if we want to understand now the role of functions as value, it is important to look at how now functions plays a role in JavaScript, which is, hey, well, it can be a procedure, it can be a function, the mathematical strict definition of a function, a set rule of a functions must set a by, okay, and these functions which we have now is functions expressions and functions definitions. So where now the association between the binding and the association between the binding and the value in the function definition happen at parse time, something that we're gonna see that later uh, in uh, in the next, or I do think is on scope and closures. yes, in that particular section. And the other is the function expression, which is, well, functions definitions or array functions that you can now is assigned to a variable, and that happen is when the code evaluate that at runtime. So because these values can be now assigned to a variable, and the concept assign or pass is something that in other languages you can specify how that works, how that mechanism works for any values. In JavaScript, this is based purely on their type of value. So for primitive value, what you're doing is just when you assign a value or you pass a value of any of this primitive, you're creating is a copy of that. But when you now is use objects, all right, you are now passing is a reference, and this is something important at least to understand, because most of the time when we understand about passing reference, uh, this concept might be quite blurry in any case. But in any, what you're doing is by passing the reference is that you have now one place or an identity, one place where this that data live, all right, usually in memory. You can think of this that it live like in a particular box, all right, or you have now a series of boxes that is that in memory say, hey, this is now the information this represent is, so all of these different boxes stacked to each other, right, represent is now an object, okay, and the value that is there, the value in its method. So because of this representation, these objects now can be used is not only as a value, but you can now is pass a reference to all of the variables that you assign to, or when you pass that value to, for example, a function as an argument. So this concept of assigning and passing value is something that is important to understand, and part of the fundamental of this particular course. Now, on that line, talking about is the functions and the assignment and passing values. Here, another characteristic of the values is that we can is now compare those values, and we can transform or coerce those values. So when we when we compare those values via a particular operation, abstract operation, which is something that the language does without your consent. So for example, like the double equal or triple equal. So you're gonna run a particular mechanism or an algorithm to determine is the equality based on its reference, equality reference, equality identity, based on that referential identity is what the name it is, right? So in other words, it's going to now compare those values is based on its identity, because there is no other 42 as a number or a boolean as a character or true or false or any of these values that can be in the primitive like undefined or null. So those values are now fixed values, okay. It turns out that, well, this kind of values, they are now compared by identity, referential identity. So they're comparing by itself. No matter how many format you can express now this value. A good example is like 42. So no matter how you can represent it's 42, whether it is as a binary here, all right, whether it's a binary or whether it's a hexadecimal. So no matter how you can represent, all of them refers to the same identity value, right? So this is what the referential identity means. So because this comparison of this value is happening at that, so if they are not the same type, then the language is going to try to convert that, to coerce that, and they have now very particularly rules to do so, right? So for example, if you want to coerce now Boolean values, all right, and what are now true or false values. So false values is a small list of elements, uh, whereas now stringed uh, has also a particular way of, for example, coerce values, whether it's from booleans or for numbers or for objects as well, right? And even for array and functions. So uh, this this coercion is something that even happened is for the for certain statements, for example, like if and while, right? And that happens is now, so that is coercing is this Boolean operation. So this is just to describe this, all right? And also is the another important piece, which is how you're going to organize your code, okay? So this code is whether it's in a class, following is this class syntax, which is just syntactic sugar, and this is a way of how you can define is a custom type of value that has data and it is own functionality, so you can now is operate on that data. So we also have is the functions, how you can create now, how you can organize your code into a function, also with immediately invoke function expressions, as well as now the recent but not that new is the EX6, which is the way of how can we organize our code. So all of this, right, via models using import and export. So all of this is just to at least have a huge overview about the JavaScript in itself, not what is around JavaScript, but now the JavaScript, uh, the surface level of JavaScript, right? Such as how JavaScript see a program, what a program is, values, the type of values. So you have primitive objects, and how inside of an object you have also is several category of objects, all right, arrays and functions. How these values can be now is represented, and how you can use those values in these containers known as variables that has several different syntax forms, and how those values can be now used as a functions to carry out this set of instructions, and how now functions are seen by the language, okay, a procedure or a function. And when you use these functions, we can also, or as a value, we can also look at other topic, which is how those values now are being used and how those values now are being compared or converted to other values, right? And if you want to now make sense of all of this, uh, especially by defining your programs, how your programs should look like, what is the co-organization that your programs now can be used, or we use to do that, right? And now looking at the digging root of the JavaScript, which is when it comes to, and this is exact, so when it comes to understand these low-level features that JavaScript has, and I do think this is quite important revealing it. These low-level features, such as these low-level features that impact on every line that we write in JavaScript, as a way to understand now the feel of JavaScript and the intentions behind that. Well, we look at the iteration. We also look at the iterators and iterables, right? The closure, the this, and the prototype, right? So all of these are features that the language now use behind the scenes. So, for example, if we do have now the need to iterate in any collection or in a collection that use a particular protocol, uh, because at the end of the day, our programs need, most of the time they are built is to process data, and well, make decisions on that data. Well, the way of how you can read those patterns will have an impact of how you can maintain that particular program. So because of that, and through the years of software engineering, uh, this pattern of has become a standard of how you can now consume is data, uh, each one at a time, at a chunk, until completion, right? So we're using is now the Iterator protocol that has now a reference to that data source, the underlying data source, that say, hey, I'm going to expose now a contract, aka a function, that anytime that you call, I'm gonna give you is the value, and you call me next, I'm gonna give you the next value, and so on and so forth until I reach the end of this. So you can now create several of these iterators, uh, to actually now iterate over the data as you need it, right? And the way of how can we consume this iterator is via the for of or the spread operator, which is behind the scenes. If you inspect at what's going on with this, it tells you, hey, whatever expression that you're passing here, and an expression in JavaScript is a value, something that produce a value. Whatever expression that you're passing here, well, now let me check if that value now contain is this particular protocol. Let me see if you have now a batch that say, hey, Iterator protocol is implemented. And the way to look at this batch is by looking is through your properties or along the prototype chain. Again, something that we're gonna see that in a moment. But we're going to see if you already have that, and the value to check that in JavaScript is the symbol.iterator. All right. So if this particular value contains that, we say, all right, it makes a lot of sense. So now this object, we can now iterate over, and this iterator or this iterable collections, and this in JavaScript we have now strings, we have map sets, or any other data structures that now produce is this iterator. All right. So when it comes to look another feature of the language, especially on functions, which is closures, and how this is being created. So a closure is defined when a functions have access and continue to have access to variables outside of the function scope within, and no matter where this function has been called or at a different function scope. So it means that these functions definitions, uh, now when you're trying to access variable from the outside scope, which means they are static, all right, is going to create now a close over to that, meaning a reference to that. And because this reference gonna live as long as you have or you use that value, as long as you execute that value, uh, this reference somehow they are not released from memory unless you explicitly tell them. And this is the source of a lot of these bugs. So closures usually we define that inside of a function or we return a function, right? And also we can now create a closure is when we call a function and by passing is the arguments to this function in some point we are defining now is a by passing is a function reference we are now referencing is to other functions as well, right? So we are creating is now an effectively a closure over those variables here. And another example is true for the for and the function because if you using now var instead of let, what happens is that var, since this is globally or function in the scope, you are passing is a reference. If for example you are now scheduling is a functions to be run at 1 second later, using is a set timers, all right, or any time that you want to schedule now a function that is going to be passed, that is not going to be executed right away, okay? So that's another way of how you can even create a closure until that function is done executing. So and the thing with for var and for let is because you are passing is a reference, and since you are passing is now a reference, in the case of var, well, that reference is gonna leave as long as that is as long as the program is finish the execution. So whether in the case of var is function or global scope, whereas let or const you create now is a new reference in each block scope. So this is the different. This is now the core of this. Okay, and this problematic things when you understand now this specific feature of the language, which is unique to functions, right? And the other is that we can also have another feature besides this closure, which is now is created by closing it surrounded, okay, via closures, and this is scope is the way of how these variables. So scope is how so scope controls how the variables and it is reference are resolved. So another feature is that that function can have access to something known as the execution context. And this execution context, which is defined at the runtime, even the name is defined, this is like an object that you can have access via the this keyword. So because of this, the value in itself that can be is this is exclusively is for functions, not for objects. Okay, so when you define now is or when you try to have access to certain properties via the this keyword is going to look at if that exists at the runtime. Okay, so for example if you do so you cannot for example do things like this dot value for example, right, and try to assign this to an object, right, because it's a this object is is that. So there is no way to have this thing. This work is only for, you can also do something like this and try to get in here. And you may wonder, why is this? This is now part of this specific use cases that this keyword have access to. So it means that because this is something that is assigned at runtime, globally, you can have access to this is with the win.object, or you can also is do something like this, and this will be and it will be the same, as you can see, you know, and this will be the same, as you can see, is the win.object. So, but again, this is something that happened is globally, all right. You can have access to this because if you now use the strict mode, it say no, this is empty, so it changes its semantic and its behaviors. So this keyword that we also look at, we can now access to this property method that we define at runtime. All right. So not only inside of a function, and when you define now a function, for example, in this case, so you say, hey, print name as a function, all right, and then you want to say, hey, console log of this, so my name is, and then you do things like this, name, okay. So what it's gonna do is that you are now defining is that this function will have access at runtime when the function is called, and how this function is called matters to this value. So if you're trying to now call that object here and you say print.name, and of course that value is not defined. So because it is a particular feature of this language, right? And if you, for example, now define is things like this, all right, you tell now to the object at runtime, you define now this value, all right, okay. What happens is that anytime that you call the function again later on, now it will have access to that particular value at runtime. You know, this is a way of how you can dynamically now, unlike closures where this is fixed, all right. Now you can dynamically add now values at runtime. So because another feature is on objects, that is the prototype, which is a mechanism of how the prototype, on how the property access is, on how property accesses are resolved. Okay, so by looking at this particular object, it's going to now, through the prototype, if you have two objects, and through the prototype, okay, you have now the A and B. So if those properties that you're trying to find on object B, they don't exist, so now let's go to delegate that resolution to object A. Again, this is part of the mindset that Kyle Simpson, the author of his book, is telling us. The question is that, is this particular mindset is true? Is this particular mindset is effective? All right, of how we can think of this, okay? And it turns out that because this delegation per object to find this property happens through the prototype change, and the prototype is now this reference that it has to other objects when it comes to collaborate to provide is now data or methods without having to rewrite them. Okay, we just only have access to all of this property to see if we have them, and we can benefit from that. We have now the data or the methods, so we can now use them. All right. I do find that that's quite revealing and quite powerful, man. Absolutely, 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 absolutely. So when it comes now to revisit this by saying, hey, because we looked at this particular property of the object can happen, and when you, for example, have an object here, and you define another object that say, hey, this is now user one, okay, and instead of having to copy this for any users, okay, you want to create now a reference through the prototype change via the object.create, right? So now you don't have is to uh, define this functionality or data. You just can't have access to those, right? Which is if you define exactly, if you define now this link, uh, and therefore you say, hey, let me now define here now username like this, all right, which is Arturo. So now username, not only that has that particular value, but also it can have access through the method print name, through the methods along this long list of cooperation, and in our case it's just two objects, this long list of objects that are cooperating to letting to have access to this property and method that they can have. So in this case, like this. So that is mind blowing, because not only that, we can also is define values at runtime that can be quite counterintuitive and dangerous, okay? But you can define uh, this objects, or you can define this new value that can happen uh, in any objects that you have, in any value that you might have, uh, which is part of the nature, the evolved nature of any software. So it turns out that because now this shape of this data can change, can be enhanced, can mutated, okay? This can be quite problematic when it comes to maintaining applications, right? So, well, this is why TypeScript now has been a powerful solution to say, hey, you know what? Let's go to now have at least if a stage where we can define all of our type annotation from this code, and if for some reason we need to enhance that, well, we're going to update this annotation before the code is executed. So we're going to define now this stage of all of these type annotations, this information about the values, all right, and then compile that into JavaScript code, that now we have certainty that it works as expected. And if there any problem, if it's any error with the value, we're gonna detect that is at build time and not at runtime. So this is huge. This is huge, man. This is huge. So when we explore now this, the practice, especially on this. So we went of how can we do this, and comparing practicing comparison, practicing closure, as well as practicing prototype. So let's get into this. Finally, let's work on this and objects link via prototype. So chapter 4, pillar 2. So define a slot machine with 3 reels that can individually spin and then display the current contents of all the reels. The basic behavior, okay, define a slot machine with 3 reels that can individually spin and display. The basic behavior of a single reel is defined in the reel object below. Okay. But the slot machines needs individual reels. Objects that delegates to reel. Individual reels. But the slot machines needs individual reels. Object that delegates to reel, and which each have a position property. A reel only knows how to display its current symbol, but as a slot machine now how to display, because how things are called, especially here, matters. So a reel only knows how to display its current slot symbol, but a slot machine typically shows 3 symbols per reel. The current slot position, 1 slot above position -1, and 1 slot below position +1. Okay, you have the position here, and the position 1. So displaying the slot machine should end up displaying a 3 times grid of slot symbols. So you get this, and then you got now this reel, all right, the symbols followed by the spin and the display. And if you can see is this. So the spin, what it's doing is to verify if the position exists, and if it is, you say, hey, I'm going to truncate that to randomly get an index instead of picking. Get a position where I'm going to put, okay, get a position here. Get a position. So get a position based on this collections of symbols, right? So give me now a random number, all right, from that max, exactly. So give me now all the model, the reminder from this operation, okay? Give me the reminder from this operation that we know that this reminder is gonna give you now a whole number, right? Okay, so we're using this math random here from this. So we are creating this math random, and then we're truncating that to only get is the integer part. No, what the French toast is trunk? Say math trunk. Say 5.3, 0.5, 0.6. Exactly. So my trunk is now getting a view the trunk bar. What is the difference between floor and math? That's a good question. Floor and math round. Math round. Oh, but this is not math round. This is math trunk. Ah, no. Trunk is different to round. Exactly. Trunk. Now, trunk say, hey, give me if the whole part of it. Yeah. Trunk says that. Trunk say, hey, give me if the whole part of that. And floor It's returning always the round down. Okay. Okay. Give me if the round down and round, say give me is now the round up to that. Okay, makes sense. Okay. So this is what it's doing here. So we're gonna get this random number, okay, that go from 0 to 1, and then this part. We're gonna multiply that, and whatever value we get from this, only give me is the whole portion, the whole number, okay, and I'm going to now is compute the remainder. So now I'm sure that I'm gonna compute the remainder of this value that I'm receiving. So therefore, I'm gonna always have a whole number until the end of this. So this is why it's doing here with this position. It's calculating is that, so which position is gonna be, all right? Right? And similar for this, if the position does not exist, but if the position do exist, it say, hey, let me now compute this, all right? So random number here, and now retrieve this value plus 100 plus this, all right? So random number here, and then now is again give me the remainder of that position, right? So now you are is like computing is the remainder, but now again based on the length. Your computing is the remainder is now based on the length here, and then the other is a display, but with a magic numbers here that's happening. And then the other is display. You say, hey, if the position does not exist, well, let me now is again compute that, okay, and assign some random position to, and I'm going to now retrieve you as one position here. Return this symbol and the position. So we got now the slot machine. So these slot machines need 3 separate reels, and reels only now renders is one slot. Exactly, one slot here. So the other is a spin with reel for each, called now spin. All right. So it's going to now compute that. And then you have the display here. And then it needs to show is in this order, right? This is the output here. Okay, makes a lot of sense. Makes a lot of sense. This is the output. Makes a lot of sense. This is the output. Makes a lot of sense. This is the output. Okay. So because display now is returning is one symbol, okay, and the position here on the slot machine, and the position here on this reel, these slot machines need 3 separate reels. And since display now is calling that, hint, use the model operator for wrapping position as you access symbol circularly around the wheel. Use object.create to create an object and prototype link to another object. Once links delegation allow the object to share this context during the method invocation. Instead of modifying the real object directly to show each of these, instead of modifying the real object directly to show each of the 3 positions, you can use another temporary object again with its own position to delegate that. So when you have your code, you're gonna have that. So that'll be all for this video. Yeah, that'll be all for this video. Take care. Bye bye.